Center. So I'm a senior scientist. So one of my main focus in my job is to develop a robotic system to automate our laboratory tasks. Yeah. So now in PNG, we have about 20 robots running our labs. Have to automate our people's scientist task. Yeah.
Thanks for the introduction. Was expecting a whole lot more, but they're very kind to themselves to us. Okay, never mind. So the first question is, so to me, we want to figure out what is CoBot, what are robots, what is Ultraman, and all the differences. So CoBot apparently is your teammate and your best lawyer wingman, so to speak, where you can just ask this obedient teammate to do stuff for you with minimum instruction sets. So in the context of Smart Nation, Chinn, could you describe maybe what are the challenges that you face that would enable the use case of cobots?
Sure. One of the major consideration for Smart Nation has always been was it useful for the citizens? And the question will keep popping up. And at a very primitive level, I would use the word primitive in a generic sense that for CoBot to be effectively used among citizens and even in a government agency, one has to consider the infrastructure setup in which these robots can be placed in. For example, when we build a smart district or smart infrastructure around buildings, we take into consideration how can we extend a robot's sensor into taking in all these different information from buildings to augment its ability to operate in the environment. One specific area I can give you where we have a team, a robotic team within GovTech that builds robots using, of course, the ROS and ROS2, and then developing proprietary codes as well to work out how it's able to deliver for assisted living. One aspect of it is how does a person that requires assistance from the environment, whether the person is living alone or they have chronic illnesses and so on, how do we prepare the space in order to understand where the person is living, how the person is living, the behaviors and all that, and have the environment that responds to it. So why I draw back to the idea of primitive is it doesn't have to be specifically a robot that is an entity that moves around in a room. It could be the space itself that has all the capabilities of a robot that you'll find encapsulated in a specific entity. And then figuring out whether you want to be able to know if the person is having heart issues. How do we use different sensors to determine if the person is healthy, is unable to get up, or has fallen, or has issues? How do we reach out to them without breaching certain privacy issues? So those would be some of the ideas that we have been working on that we are looking at collaborative AI technologies for assisted living.
Thanks, Chinn. Zhan.
So I think, because Flexiv is mostly in the area of robot manipulators. So the examples that I can share is mostly in terms of like manipulations. So I think for us, what we see mostly for industry is that people still mostly look into either total automation or manual operations. But there are some cases which, based on what I saw, is that there are some cases where certain things to be done is still very hard for full automation. So you cannot expect certain things to be done 100% successfully based on current technology. An example which I can give which I gave over here is the harvesting of a plant. Let's say harvesting of a vertical farming plant. So in this case, it may seem very simple for humans to do, but if you ask it to robots to do this task, 100% of the time, 100% accurately is almost impossible. So this is the area which I think human robot can actually collaborate quite well, in terms of that the robot can do things very precisely, and accurately. But in terms of the AI aspect, especially in terms of handling failures, is not as good as what a human can do. Just because, you know, to do things, one thing successfully is just one path, right? But there are so many ways in which certain things can fail. So I would say the current state of AI cannot really handle all these multiple cases of failures in which it can occur. So how I see is that we can actually ask the humans to collaborate with the robots in the sense of handling failures. You know, the robot itself must know that, okay, there are certain things which I have done wrongly. And then you can ask the human for assistance, either, you know, through an interface in which the human can guide the robot to correct certain corrective actions. And then after that, the robot can resume the task based on this, like, this known thing that the human has actually corrected. So actually, this is how I think human-robot collaboration can bring forward automations for certain things that is still not possible to be automated 100% through a full autonomous operation. Yeah.
Over to you.
Yeah. I'm more like I'm more a hardware guy. I'm more a servo guy that trying to apply actuator into different configuration of robots, from arm to mobility stuff. And my background started off as surgical robotics kind of developments many years ago. And then we chanced upon some opportunity in the hospitals. Then we went into doing some robotics beds and stuff like that. It's more on a bit of the automation side, which is from the surgical OT that go up to the patient service side itself. Now, there are quite a number of AI stuff that apply on image analysis and whatnot itself, and even on the assistive side itself. But to be honest, for the 10 over years that I've been working, trying to do healthcare automations part of it, the issue is I see that more and more is a bit on automations rather than autonomous part itself. The real autonomous part, AI and very intelligent, intuitive, I think is a bit far at this moment. And what he has been mentioning just now is like error recovery and whatnot, because in real applications, right, we let the nurses or the porter auntie that's doing something using the systems, it is intelligence, but we need it to be able to auto recovery when there's error, whatever, done by this level of people. We cannot have a very high-end engineer sit there and look at it, so it's not sustainable. So to be honest, my experience to date is that I have not seen really very intelligent AI stuff that's very sustainable. It could be just POC and that's about it, you know, at this moment. So more to it that is sustainable, some form of automations, some form of very specific tasks itself. It cannot do many tasks. We cannot be too greedy. We have to be very clear what we want, and they're very specific itself. And then to deploy, right? So the more we want it to do, actually, the more failure it may be, because it may do it in the classical case, but then when the environment change a little bit, then things are different. So it's not sustainable from that point of view. So really look forward that the collaborative part, the AI learning part, really can auto self-recover and whatever when there's something happen in the intended operations of whatever you guys are creating. That's what I'm thinking of. Yeah.
Thanks. We should meet up after this. But okay, over there.
Okay.
Haibo, you're actually using some cobots in your lab.
Yes. So I want to talk from R&D point of view. Like, I think the CoBot has a huge potential in lab automation. I give you some numbers. Have like in P&G we have hundreds of brands, right? And globally we have like 20 plus R&D centers. You may be, and like each brand has a lot of products. Like every year we have new products, new package design, new formula design, and all these new product release, we need to do a lot of testing on the package, qualification, reliability, formula performance. And you may be surprised, all these tasks actually all done manually. Yeah. So like in Singapore, we have in our labs, like half of our office space is all the labs. And in our labs, we have like about 100 lab assistants. They just do those kind of repetitive test methods, run those repetitive tasks run test methods, prepare samples, do the labeling for the test samples. Yeah. So there is a huge potential like for cobots to help us to automate these test methods, right? All these tasks. Yeah. So those traditional automation solution actually is not suitable for R&D because our automation needs change very fast. Usually a project runs several months, they not closed. With that time, it's not enough for you to develop an automation system yet. Right? But with the CoBot, it's very flexible, right? Very general. So with CoBot, actually, we can do automation very fast. And even with the existing system, with the CoBot, we can also change the purpose and for the new modify the robot for the new test requirements, which is very easy. Yeah.
Okay. Thanks. So I started this thinking about how a robot could be assistant to human, but what I heard is the other way around, that the robots actually need human to collaborate with them. So that so Chinn, what do you have to say to that for your space concept?
Something to look out for probably would be next year. We've been working on Punggol Digital District, which is intended to be a smartest district in the world. That's the goal. The idea is, how do we create area something between 5 to 50 hectares to be ready to engage the robots that will run around it. So it is not just a robot by itself doing its work. It's also the environment providing the necessary information for it to survive and do well in the environment. From last mile delivery, because it's able to move from point A to point B, being able to call the lifts and go up certain places where otherwise the door won't open, right? So how do you build such an environment for it? So along those lines, we've been thinking very hard about it. That's very much on robots from a very physical perspective, but we have also from the government perspective been using the digital robots, how we do the robotic processes agents. What that basically does is that emails, claims and everything, we built a robotic automation system that allows it to know what it is supposed to do with the information that's come to it, the digital information, and then route it to the right people or automate the processes that it goes through. That would alleviate 50% of the heavy lifting when you have to actually understand the forms that come in. So between the physical world and the digital world, and if you can imagine, the government has a role to play. The role to play is basically building the best infrastructure that is ready for robots to thrive in, and allowing that communication in a secure manner. And then from that space, cobots can be able to engage with the people that use that space. So that's where we are aiming at. If you're interested in finding out more about this, you can Google Punggol Digital District. And it's a very important space, and you will see a lot of cobots and robots running around there next year. Okay. Sure, it's the northeast of Singapore. No, it's next to an island called Coney Island. There are a lot of plants in that area. It also connects to some 300 kilometers of the park connectors. So if you think about Singapore from this perspective being northeast, eventually going down to Paya Lebar area, then going down to JLD, JID. The partner agency we work with is called JTC, Jurong Town Council. They own about 10% of Singapore land. So the idea to create the smart district there is, should it when it's shown to work, there's a potential to change 10% of Singapore. Short answer is yes. Our team, together with GovTech and JTC, have met with them, And the team has actually gone to Japan and spoke to them on how we can exchange certain ideas, because in Japan, they suffer from entire villages being depopulated. Then how do we use technology to reverse some of these things? So these are the conversations going on. Not just Japan, there are a few other countries as well.
Thanks for the exchange. Zhan, in your so you've got a couple of robot platforms and products that are pretty much ambidextrous and highly sensitive. What kind of tasks would those be applied to in this smart city concept?
So I guess it's still, I mean, we are more on the low level. So in the sense, I guess he had mentioned about the higher level plans for the Congo digital districts, but for us, I think it's still more on the realization of it. So with Flexiv, I guess it's mostly on manipulators. We have manipulators that is like a human arm that can sense forces, and you have that dexterity to do things. But ultimately, I mean, on our side, we are still we promote ourselves as an adaptive robot, but as I said, I think it's still a long way to achieve that level in which we can replace a human, like totally replace a human to do things that current human can do. So we are still, I'll say, working on it. Yeah, and currently what we see in the trend is that there's the trend towards a low code or even no code programming, so people can actually use the robots easily to do things that they want to do without the involvement of engineers. Just a normal person, a lay person can actually program the robot to do what they want to do. Yeah.
Okay. Yeah, thanks. I noticed that in the book that I gave you guys, there's a MATA thing. You want to talk about that and in the context of
in this
CoBots.
book, if you flip, there's one project called MATA, which is the security robots used by the police itself. This project is actually in collaboration with HTX, the technology arm of the MHA, and together with A-Star itself. So SIIX-AGT, we are the supplier of their hardware base itself. We started the project 8 years ago. What you see in the book is version 4. We did it from version 2 all the way to version 4. So what has come out from there is that it has a very actually, the robot is quite robust and says that all the best navigations and all the different sensor technology and the robot logics that is built to the requirement of the HTX for their deployments itself. And then in order to meet that itself, we have to actually custom make everything from the motor driver all the way up to the systems to be able to handle the multi-terrain from indoor to outdoor, able to climb curbs itself. So, and with that itself, SIIX-AGT able to generalize the base itself. And the base also has been used in some of the SCDF projects in the HASMAS stuff that you may have seen. They are used on a similar base. It took us 8 years to work out that base, but it took us about a year plus to 2 to configure to a different applications. So with respect to digital stuff, if you want to do the last mile, whatever, that base is very suitable for outdoor multi-terrain. I think that I remember that I'm not sure it's still the case or not. Beginning this year, there's only, if you want a robot to move on the pathway, you need to pass the CTRAN test. I think there's only 1 or 2 companies that make it. So MATA is one of them that passed the CTRAN test itself. So it is able to meet the requirements to go on the small pathway and things by the LTA. Right. So if you guys have any needs for the base, which is made here, every bolt and nuts, you can come to us. And since we make the base up all the way up, we can easily integrate many other payload, including robot arm and CoBot arm with the base together. It's kind of growing trend also in some of the automations, factory automations. People are also looking at taking the arm and put on the base itself. So you need a lot of integration from bottom up itself. So the base is able to take different arm, and the base also is integrated with Theta. UAV with Theta systems that can fly up to 30 meters. So basically, they're all completely closed loop. The flying itself, the tethering control, and the robots are all in closed loop because we wrote all the drivers in it from A-Star's algorithm to ours. So there's no black box basically, and we can tweak it customized to our need. I think that's the key part of it. Yeah.
Well, it'd be interesting for both Flexiv and SIIX to consider how this can be personalized by having individual officers or, in whatever capacity to instruct, to just provide demonstrations to your robots and then turn them into cobots and then have them assist back the cobot. Right now it is right now the technology is pretty much straightforward, right?
Yeah.
You program it
Yes.
in a linear fashion.
Yeah.
And if you see those demos out there, you see nascent technologies that will allow you to instruct the robot and train it by demonstration. Did I get that correct? Yeah. Okay. I think I get that correct.
I think that's very important because now whatever we do, the engineers have to spend a lot of time to custom build the robot characteristic to that applications.
Yeah.
But then if the user want to change the application a bit, the intention of the robot a bit, it's not that easy for the end user to really teach or, to get the robot to do it. But if this bit of it this teaching or this changing of usage can be easily done, I think that will make the robot intuitive and easy to use, right? But now it's very scary. You need very senior engineers experience to tweak it, right? So this is the stage at the moment. Yeah.
Okay. Now to the actual user of a cobot. The room and these three gentlemen here, give us your wish list.
Yes.
For example, right, there are many things that you're using and they're not fulfilling yet, right? Your current needs.
Yes. So as I mentioned, we have a lot of use case need to be automated in our labs. And currently we only have 20 robots. I will foresee like when we need 100 robots to do all these jobs in our R&D center. I'm also a user, I'm also a programmer. So I do the hardware development, software development. Right? So the challenge I foresee is it's not from hardware. The current robotic arm, collaborative robotic arm is very safe, very capable. So we have a 3 kg, 5 kg, we even have a 16 kg, 20 kg, right? And also we have a 2-finger gripper actually can do like, even if it's not 100, I think it's 80% of the job in the lab can be done with the 2-finger grippers. And also we have a 3D printing technology, very easy for us to make new accessory tools, very fast iteration. The biggest challenge I encounter is from software actually. So I see all the use case which demonstrate today is very simple use case. You have a clean table, you have a very small object, you just pick and place. It's not the real case in the labs. The labs is very crowded, right? And so your robots is crowded with instruments, test samples, because you want to run the robot with as many test samples as possible. Sometimes we need to load like hundreds of samples, and you may need multiple small bottle, big bottle, right? So it's very crowded. And so you also have like maybe like 20, 30 steps to complete one task, right? And with this crowded environment, there's so many steps. So program the robot motion is extremely challenging. You like a lot of time you need to consider like cabling, collision avoidance, yeah. And you need to grasp the bottle. Sometimes you need to grasp the bottle from the top. Sometimes you need to grasp from the side. And you need to have a clearance because you are so crowded, you need clearance between the different samples. So I was trying to incorporate like a motion planning or those smart way to simply like to ease my programming effort, but it's not robust, right? So if you really want to navigate from this very crowded, challenging motion, you have to do it manually, adjust your position. Like sometimes I spend like 10 minutes to align one point, and in my simple task I need like hundreds of points, waypoints, right? And again, like if you need a modification, of course it's very scary to the end user. They have to ask my help. And another challenge is in the lab, we are very crowded, right? So usually, and we don't run the test day and night 24/7. So one test may be run a few times a week, right? Then we want to put the robot for other activity or put it aside. Then you need to move a robot, or you want to change it to other purpose, and then you want to move it back. And all the pose you need to readjust, right? Yeah, I know there's some visual computer vision can help us to do this. Yeah, but again, it's not universal and sometimes it's not robust. Yeah. Unfortunately, today the most robust way is still use a fixed point positioning programming. That's the most robust way to do this, like 100 steps tasks. Yeah.
Thank you. I'm going to appeal to Chinn now to share your insights being a Stanford cohort and your ability to get the first Boston Dynamics robot patrolling the city. I don't know if your whole team of 6 stealth engineers are still around.
Yeah. Okay. So what he was referring to was Boston Dynamics never wanted to bring robots to Singapore, their robots, because they think we'll dismantle it and copy it and sell it to China or something. No, we didn't. But because I had a relationship with them for quite some time, I started a company. They bought my company, so, and I worked with Boston before I was headhunted to GovTech. And I was talking to them and said, there's a platform they have which is pretty advanced. So could we just use it and we learn from the capabilities what we can develop from there, so that we don't have to get to the nitty-gritty parts about its ability to be aware of its environment, going upstairs and all that kind of stuff. So what we learned from that was that robot by itself, as intelligent as it is, should not be seen as an isolated system. It requires the entire infrastructure around it to give it its awareness. One good example is the point of view, right? If everything is on the robot, it's only seeing from its point of view. And let's say there's an exit door it wants to open, and there's somebody coming out because it's swinging back and forth. Would it command it to swing open and hit the guy that's on the other side? So then how do you actually solve this problem? You actually have to think of it as its entire system, a system of systems, because everywhere there's CCTV camera, you need to be able to extend the robot ability to see beyond line of sight. In other words, before I open that door, I'm aware there's a camera there, there's a person. So I don't open the door. I don't command it to open the door. Or if the system is around it and the robot is saying, open that door, it knows because of the camera system, there's somebody behind it. It won't open the door, but then there's a queuing system that allows for the instructions to go through. So all this plays a very significant role into how robots can collaborate and co-live with human beings. So the lesson that I would, or the suggestion I would have for robot makers and software developers is, don't think of it as the only solution available. You have to think of it as a system of systems, and make use of the environment sensors to give its super sense capability. And so then it can perform very well. As far as manipulators and all that, I think we've done some research. Coca is pretty good at it. And then a lot of these things we think, rather than reinvest, we will just buy off the shelf. So that's good news as well, in the sense that we don't have to build everything ourselves. We take what's the best out there. But what, from a government perspective, we can do is, how do we open up the environment to robots service providers, so that these capabilities allow for the robot to excel in what it does very well. I want to end off with a quick note surrounding cybersecurity. We take cybersecurity extremely serious. If it doesn't pass it, our robots won't go out. So for the district that we've been building, it is an air gap solution. In other words, it's isolated. It doesn't talk to anybody outside. It only talks to its own data center. And because of this, the messaging is encrypted and so on, so that when you work in such an environment, you don't have to worry about being spoofed or somebody hijack something. You want to create that environment that's safe. More so, especially not just from hacking and phishing and all that, but it's more so if you have a Collab AI capability within it, right? Because you're actually dealing with different parties, with different people. How do we create that secure environment? This is actually very critical for us. So not just a space for robot to be able to do well, but also in a very safe and secure environment. Is our objective.
Thanks, Chinn. Zhan, where do you see your robots moving towards higher sensitivity, I guess, and also more dexterous? I don't even know how to ask those questions. Yeah.
Hello. Yeah, I guess I would see our robots going towards more. I mean, on the hardware wise, can always be more sensitive, and the software can always increase its AI capabilities. But I think it's really on how do you actually integrate the information, because I mean, right now, when we do certain things, you either use just vision as what the PNG, I guess I forget the name, sorry.
Haibo.
Yeah, you mentioned, is you use the vision to look at things, and then after that, you perform the action. But there's seldom integration like a human does. We always use our senses from the body, our fingers, our tactile sensors, and also our vision to do things together. I think that's certainly lacking in today's robots. I just refer mostly to robot manipulators because that's what I do. So in terms of robot manipulator wise, this is something that is